Welcome back. So in the previous question, let us take the position of mass when the spring is unstretched as x equals 0 and the direction from left to right as the positive direction of x-axis. Give x as a function of time t for the oscillating mass if at the moment we start the stopwatch, that is when t is equal to 0. The mass is at the mean position. In what way do these functions for SHM differ from each other in frequency, in amplitude, or the initial phase? So amplitude is 0.02 meter. The time period is omega, that is omega equals root over of k by m. So if we put in these values, we get the omega to be equal to 20 rad per second. Now at t is equal to 0, the mass is at the mean position, that is at t equals 0 and x equals 0. So x as a function of t equals 0.02 sine 20t. Here x is in meters and t is in seconds. Now, uh, in what way do these functions for SHA differ from each other in frequency, in amplitude, or initial phase? When at the maximum, the mass is at the maximum stretched position. The amplitude is 0.02 meter. The time period is omega. So omega, we already know the value of omega, that is root over of x k by m. So we need to put in the values, and eventually we get the omega to be equal to 20 radian per second. Now at t equals 0, the mass is at the maximum stretched position, that is x of 0, x at 0 equals a, and phi is equal to pi by 2. So xt is equal to 0.02 sine 20t plus pi by 2, and xt again, and this is again equal to cos 20t. Here x is in meters and t is in seconds. Now uh, in what way do these functions for SHM differ from each other in frequency, in amplitude, or the initial phase at the maximum compressed position? So amplitude is this, time period is this, and at t equals 0, the mass is at the maximum compressed position. That is x when 0, t is equal to 0, is equal to minus a, and phi is equal to 3 pi by 2. Now x as a function of t becomes 0.02 sine 20t plus 3 pi by 2, that is equal to minus 0.02 cos 20t. Here x is in meter again and t is in seconds. The above functions differ only in the initial phase and not in amplitude or frequency.